Hi and good day. My name's Don Pannell. I'm a fellow at NXP Semiconductors, and today I'd like to talk to you about the status and content of the IEEE TSN Automotive Profile. And I also want to thank help and support that I got from Craig Gunther, who is the editor of this TSN Automotive Profile. First, I want to cover how 802.1 works. Now, a lot of the IEEE standards groups have very similar techniques and how they do standards, but each group is slightly a little bit different. So I think this is worthwhile for you to understand how it works and what a profile is versus some of the other standards. And then I will cover the status of the automotive profile and cover its content, followed by a summary. So first part is how 802.1 works. And I've given a link here to the web page or a document actually that the chair of the TSN work group has written as an introduction. So if you, this will cover a lot more information than I cover here. So if that's something you're interested in, that's a good reference. So in summary, I mean, what is 802.1 and how it works? Basically, it works on three types of standards development projects. There's base standards, amendments, and revisions. And base standards are standalone documents. They use uppercase letters in the name to indicate the document is a base standard. And that's been the mechanism that's been used since about 2003. And so 802.1q is a base bridging standard. 802.1 AS is a precise timing base standard. And then 802.1 CB is the redundancy standard. Now, amendments to base standards are updates to the base standard where only the project's changes are open for ballot comments. And we'll cover more why that makes sense. Now, they use lowercase letters in the name after the uppercase letter of the base standard being updated. So for examples, 802.1 QBV, you get the capital letter Q is the bridging standard, and BV was the time-aware shaper standard that was an amendment added to Q. 802.1 ASDM is a new in-process hot standby standard to the latest AS base standard. And then CBDB is enhancing stream ID identifications for the redundancy standard. Now, revisions to base standards are used sometimes. They update a base standard where the entire document could, and I do stress could, be open for ballot comments. It's used to roll up amendments into a new base standard. And in this case, the scope prevents feature additions. And I'll explain a little more next here. It uses uppercase letters followed by rev until they are complete, where the rev is replaced by the year. So 802.1 Q-2020 is the latest Q rev, and then AS used to be known as AS rev is now AS 2020. So examples here is the Q rev, which is what we do to roll up. So when QBV was done and it got rolled up into Q 2018, that was a roll up, and it took QBV plus many other Q standards or amendments that were completed at the time and rolled it up. Now that's such a huge document. In that case, we only wanted no feature additions were added. It was basically just rolling up the existing standards, and so it was finding errors, corrections, things like that. So the whole document was not open to be interpreted. Now the AS Rev, which was the previous PTP standard, the entire document was open, and that was some of the reasons why that took so long on that project. And so that's why 802.1 generally does not do revisions. We do them mainly for roll-ups. Now within those three types of standards, there's mainly two categories that are focused on. There's a standard, that defines features, protocols, and how to manage them. And many standards have both mandatory features and optional features. And it's like the optional features are there for if you implement a feature, then this is how you should do it, or you shall do it. Whereas mandatory features are very important, like for interoperability or to do enhancements to the standard that are backwards compatible, which is a key goal of 802.1, is that then you need to know that any revision of the standard mandatorily checks the revision field in the frame to make sure that it knows what it's supporting and it can support. Now, a profile is a standard that defines a set or subset of base standards, so a collection of base standards that are needed for an application, along with defining which optional features are now that were in those base standards that are now mandatory to be conformant to this new profile. And so, for example, no product in the world implements all the features defined in 802.1q. There's so many dealing with provider bridging and small bridging and automotive and industrial and so on. And there's just no product in the world that does implement all the features. So there are a lot of optional features. But now when you want to bring those bridges together, like for AVB, which was the first audio video bridging profile, and then you need to define which features are now that were optional in Q are now required in order to make it that whole use case work. And sometimes you'll disallow certain things as well. So profiles can't define any new features or protocols. Instead, it defines the conformant set and can make things that were optional in the base standard now mandatory in the profile. And the list of 802.1 TSN profiles, so this is just the TSN profiles, and those that have a date on them indicate the year they completed. So the first one was 802.1 BA, which was the AVB, really the plug-and-play audio-video bridging profile use case. And it was the first TSN profile. And in fact, to make that plug-and-play, and at the time in 2011, nobody expected there was going to be any half duplex or 10 megabit media being used, as it is now coming back, and particularly for automotive and industrial. There wasn't a view at that time, and to make plug and play work easier, it was much easier to limit and disallow half duplex media and disallow 10 megabit. But that's only for this plug and play audio video bridging use case. That's not to say that automotive or other use cases can't use shared media and can't use 10 megabit. They certainly can. It's just that it would be in a different profile because maybe a little bit additional work needs to be done, etc. But that's what the choice was at that time. It doesn't prohibit it, it only prohibits for that use case. The next one was CM, which was a front haul network profile. 60802, which is a joint IEC, which is why this has like an IEC number on it, is a joint profile for industrial automation. DF is a profile for service provider networks. And DG is the one I'm talking about here today. I'll add more information about it, is the TSN profile for automotive in-vehicle Ethernet communications. So how does 802.1 work in developing a project? First, you start with ideas. You get a new idea, and their presentations are made showing there's a need and a market, and you develop consensus within the group that this is a good thing to work on. And then a project authorization request is needed, a PAR, and that's to get official IEEE approval to work on the standards development. Since we're going to be spending time working on this within the meetings, it has to be, there's a procedure to make sure that what we're working on are things that the majority of the people feel are important to be worked on. And so again, there needs to be enough of that support, and that's why you do this idea presentation phase. Then once the PAR gets going, you go into task group ballots, where you collect requirements and features with solutions, and you work those out, and you get everything figured out. And anybody can comment and vote on task group ballots, whether you're a voting member or not. That includes all you out there in the audience. Then working group ballots is when the solutions that were defined in the task group ballots are validated. And again, anybody can comment on the work group ballot phase, because in 802.1 all comments are addressed, but only 802.1's voters count whether the ballot is going to pass and go to the next level, which is SA ballots, which is a Standards Association ballots, and that's the last IEEE step. And it's used to verify that all IEEE procedures have been followed, everybody's comments have been answered and addressed and listened to, etc. And anybody can join the SA ballot pool and comment and vote on the ballot. And after that passes, you have a standard, it's complete, and then it's published. So what is the status of the auto profile? And here I've given you a link to the status page where all that's continuously updated with links of new public presentations and where the drafts are of the standard, etc., the whole progress. So that's a good link to know about. So here's where we are on the timeline. We've had the idea phase, we have the project, and we're in task group balloting. And so the PAR was completed in February 2019. And then we had a number of non-balloted drafts. So those were just ideas and seeing where we're going. And we've had 2 drafts that have been balloted on. And these initial drafts have been focusing mostly on informative tutorials and the document structure. We're trying to get consensus that the editor's going the right direction. The project is currently in task group balloting, and again, that's that phase where requirements are being collected. So this phase right here is a really key important phase, and this is the time for more participations from OEMs and everyone else in the audience here, so that all your needs and requirements are included. So please, if you feel, you can see what's being discussed, I'll talk about that following here. And if you don't think that your needs are being looked at, then please let us know. Please get involved. And it's mainly during this phase. You don't have to be involved in the whole process, the whole group. It's just, this is the important phase to get your requirements in. Now, all the projects, the PAR, one of the main things the PAR does is define a scope and purpose for the project, and that's to help make sure people really understand what the project is, where it's going. And the project scope, I'm just going to read this literally because it's really important for people to know that exactly what the scope is. It is this standard specifies profiles for secure, highly reliable, deterministic latency, automotive in-vehicle bridged, IEEE 802.3 Ethernet networks based on IEEE 802.1 time-sensitive networking standards and the 802.1 security standards. It's a lot of words, I know, but it's very specific what it says. And the project's purpose is this standard provides profiles for designers and implementers of deterministic 802.3 Ethernet networks that support the entire range of in-vehicle applications, including those requiring security, high availability, and reliability, maintainability, and bounded latency. Now, while 802.1 profiles are not allowed to create new features or protocols, as I discussed above, if any deficiencies are found, the IEEE 802.1 group can and has started new amendments to improve existing standards. And of course, the earlier these deficiencies are identified, the quicker they can get fixed. Like ASDM, as I mentioned earlier, is an amendment to AS. Then it covers hot standby. That was a need that the industrial profile was finding that was not covered in AS, and it was not something that could be defined in a profile. And so the profile started the amendment to do ASDM, the hot standby project. So that is really good. And thus, this project is requesting all use cases, and this I mean 802.1 DG, all use cases, even those that go beyond 802.3 networks. So like in order to solve a problem, there may be car-to-car communication paths that need to be considered inside the in-vehicle network, but the use case clearly goes beyond just the 802.3 Ethernet network. So help us work beyond those boundaries as well. We may not be able to solve all of those networking problems that go beyond the 802.3 Ethernet networks today in this project, but we'll know where to go in the next steps. So to show a list of contributors, I have a list of presentations in the newest to oldest order, and who the contributors were and their affiliation. And I think you'll find quite a number of, I have 2 pages of this, so this is just the first page, of a number of OEMs and other people greatly, very much focused in automotive markets. And we've gotten some great input, and of course we can use more. So again, each of these presentations is available. I'm not going to go through each of them, but here's, and again, this is a partial list given since the PAR was submitted. There are others, and so you can see some of the people. I'm sure you recognize a number of the names. And for the complete list, again, you can go to this link and find these presentations. These are all public presentations, and again, verify whether you think these use cases are relevant or not. And if you don't see anything that covers your use case, again, that's something that we'll talk about later, how you can help. So what about the content of the automotive profile? Now, here's a link to where the drafts are, but please be aware these are password protected, and I'll explain more how you get that password. So 802.1 DG is doing something very unique. It's going beyond what many standards have done in the past. Most standards only define what is required. They don't give you the history of why and the subtleties and the things to look out for. But what's been focused right now in the document, and there's been a lot of good review of this work, is to help readers understand the subtleties and side effects of various features, like, do I really need P delay in PTP? Do I need in-order packet delivery from CB? Do I, these various things. There's a lot of subtleties in the base standards being used. And so a system level tutorial section has been worked on and has been added. And this information is in an informative annex, which is called TSN based network design considerations. Currently, the drafts include FRARE or CB redundancy and AS 2020 PTP. And those discussions include in-order versus out-of-order packet delivery, intermittent stream versus bulk streams. What are they? Individual and sequence recovery functions and why you care. When P delay messages are needed. They're not just there to measure the delay of the wire, which the name implies that, but it does so much more. The concept of multiple clock domains and timescales. So, and future drafts plan to include tutorial topics on filtering and policing and on scheduled traffic. So topics get added based on need, use cases, and on input from participants. So there is, again, where you guys can help and say, I'm confused in this section. How do we, I don't understand this standard. The initial drafts have focused on the tutorial, with the future drafts mainly focusing on the profile. So we're that's what these first drafts have been on. So that's a good read. So getting a copy of the draft and then reading the tutorial might answer a ton of your questions right off the bat. So here's the document structure so far. And again, this is likely to change over time because this is only draft 1.2. You have your normal front material, and then you have scoping and addressing, life cycle. A lot of these are placeholders, and so we have to decide whether we keep these placeholders in. But you see a lot of other things, methods for separating traffic, PTP levels of robustness. The real interesting section, though, is going to be the profiles, the main section of the standard. Now, what I don't have on here is the annexes, and the Annex E is the one that's the tutorial section. So what about other potential content? Well, 10-base T1S considerations. As I mentioned, a lot of TSN work prior to this did not cover a lot of concerns about half duplex or 10 megabit, but now it's becoming very important again. So 10-base T1S has been brought up, but without other standards work, TSN support is going to be limited. For example, PTP currently does not support the multi-drop media, so we'll need an AS amendment. And there's a desire, at least from a presentation that was made recently, that for any changes in AS to be minimal, so that bridges that have multiple ports, some with point-to-point links and some with multi-drop ports, can use the same software stack. And I have to back that idea up if at all possible. It makes a lot of sense. So, but some work still needs to be done. It's also lacking differentiated services, or priorities are not supported on the media. Now that will need 802.3 support. Now, what the differentiated services do is reduce the worst case latency on critical flows, but right now it's still very, 10-base T1S is deterministic, and you can, if you take into account this lack of differentiated services support, things can still work for you. So that's may not be a problem. So that's why the question, are either of these features needed? Please let us know, help us drive these, because again, if we need an amendment to AS or work with 802.3, the earlier that starts, the better. Again, so possible AS amendments, I've added in the 10-base T1S. There's no PAR on that yet. It's just at an idea stage. And define the hot standby for redundant PTP clocks. Everybody, that's redundancy is becoming a big issue. And 802.1 ASDM, which was, that PAR is approved, and that's being done for industrial automation. However, I'm sure a lot of this work will be applicable, and we need to pay attention to it so that we can use the same work, if at all possible. So in summary, the project is well on its way with a proposed document and profile structure. While multiple contributors have presented many use cases and requirements, again, they're all publicly available in the links I've given you, your needs may not be worked on, simply due to them not being known. So please consider participation in this phase, that work group, that task group phase of the project, of the standard development, by contributing. And maybe some of your ideas, you want them to be anonymous. You don't want them tied to a given OEM or anything else like that. That's fine. So for help with that, please contact the DG editor. Craig has given me his email address, asked for that to go be published here, so that if you feel you want him to contribute for them, your ideas, then please, that can be done. We really want the ideas any way we can. The extensive tutorial information added to the profile is new, as I mentioned before, for the 802.1 standards. It's just going to be very great having this tutorial information. And I really believe that this standard will become the go-to document for how these standards work kind of information. So this is going to be an important first read for a lot of people. And I think it will explain a lot of things people didn't realize the standards did. And it's like, oh, I didn't realize that's subtle. I didn't know that was that important in the standard. And during standard development, the drafts are in password protected area. I mentioned that before. So to get access to this tutorial information now, you need to participate in the standards work, as the password is available to participants. To become a participant, here's a link to the DG page. Then scroll down to joining the task group and voting, and then click on the join main 802.1 list link. And then through that process, you will then have access. So really the bottom line here is help us ensure this profile is relevant to you. There's a lot of people working on it, and we really want to make sure this is relevant to you and the industry as a whole. So thank you very much for your help and consideration. Now we are open for questions.